Hey guys, welcome back to the channel. In this video we'll be solving this puzzle called Collections.deque. We'll be using it basically. Here you can see if you want to know more details about DQ, you can follow this link. Okay, it will go to Python docs and you can learn more about this. So we'll be using some techniques from DQ. What is a DQ? A DQ is a double-ended queue. Queue you might be knowing, just like your bank lines or whenever you go to McDonald's there will be a queue, that kind of sort of thing you can imagine, but it is a double-ended. Okay, DE means double-ended. So double-ended means you can add or remove elements from both the sides. That's what double-ended queue means. DQ support thread safe, memory efficient appends and pops from either side of the queue with approximately the same order of one performance in either direction. Okay, because it is memory efficient, that's why we use DQs. Okay, if you want to learn more about its techniques and methods, you can play around, okay, by following this link. Now there are some example code you can see here. First of all, you have to import a DQ from collections, then you have to define DQ and it is represented by D here, you can see. Then you can play around. D dot append, if you will do 1, then in DQ you will have 1 being appended. If you will append it from left side, you will have like this, from the left side has been appended. Generally it will append from the right side, but if you will write append left, the elements will be appended from the left side. D dot clear will clear your whole DQ, you can see here. Extend will extend your DQ. If you will do this thing extend 1, here you can see the difference between append and extend is you have to use this the inverted commas in extend, whereas it is not necessary in append. You can use both, without inverted comma, with inverted comma. Okay, then one more difference is there. So here you can see after clearing DQ you have extended it to 1. Then you can see you can extend from left side as well, but the difference here is you can see each of the digit will be treated as one number. So first 2 comes, so 2 has been appended from left, sorry, extended from left. Then 3 comes, 3 has been extended from left. Then 4 comes, 4 has been extended from left. Okay, if you do D dot count 1, that will count the number of these guys. Okay, because the input is this 1, so it will count, only 1 is there, so 1 times it is there, so it is basically counting the element. Okay, how many elements are there, same with this element. So that is also something you can do. Then you can do pop. Pop will eject out the last element from the DQ, so it is 1, that's why it is called here 1. If you want to remove it from the left side, then you can use something called pop left, and it will remove from the left side, so 4 will be removed, you can see here. Okay, then if you want to extend a 7 8 9 6, then you can see from the right side 7 8 9 6 has been extended. 7, then 8 comes, then 9, then 6. Okay, if you do this same thing with append, what will happen, it will take it as a whole number, 7 8 9 6 it will append. Okay, I'll show you. Let me copy these guys here. If I'll write so it has been imported, D print D, right? So if you will append 1, you can see 1 has been appended. Now let me append 1 2 3 4. Okay, so see what it will show. So it will append 1 2 3 4, you can see, as a single element. Now if I'll use extend, then this is what happened. It will treat it, each of the digit will be one element, you can see here 1 2 3 4, right? You can also use append with inverted commas. So if you will see, still it will be one element, but with inverted commas, so it's basically treated as a string. This is just to show you the difference. And then there are other techniques as well, like remove. If you want to remove something, just type what the element you want to remove, it is removed here, you can see. Then you can reverse the queue, you can see 6 9 8 7 3, is reverse of this reverse order. Then you can rotate with 3. Okay, if you'll print it 3 times, it has been rotated. You can see 3 was here, 1 2 3, 3 times it has been rotated. Then 7 comes, then 8 comes, then 9 comes, then 6 comes, right, like this. So it has rotated in from left to right. Okay, so it's clockwise, means like circular rotation. Okay, so last guy will come at first, type of thing. So these are some techniques you can do with DQ. So that is basically the introduction of DQ. Now what all things we have to do, we'll see. So task is to perform append, pop, pop left and append left methods on an empty DQ. So it is similar to what we have done in the last exercise. You can see the first line will have the value of n, how many number of operations you have to do. Then the next line will have the space separated names of methods and their values. So you can see here an example. So 6 operations will be performing, 1 2 3 4 5 6, and you can see each of them. Okay, so append will require some values, append left will require some values, but pop will not, and pop left will also not require. Okay, so for all 4 of these we'll be writing the similar kind of stuff. And at last the constraint is n has to be between 0 and 100, operations has to be between 0 and 100, and finally we have to print the space separated element of DQ. Okay, so let's do it. Here you can see 6, and after applying these operations, you are left with 1 and 2 that you have to represent with space separation. Okay, so let me write the code. So first of all we have to import the DQ. That is something we have already done, and we have initialized the DQ D. The first thing I'll take is the value of n, int input brackets, right. So now we have the value of n. So for loop I'll use for operation in range 0 to n, right. So just whatever we have done in the last exercise, that is same thing we are doing. Now let me take the variable a again, so that we'll take the input dot split, right. So it will split. If you wanna see it, same thing, a, run the code. So you can see all the inputs operations, right. Now we can access them element wise. So that is what I'll do. If a, I'll remove this, if a equal to a0 equal to append, then it will perform append operation on DQ, right. So d dot append, and since we need it integer type, append these guys has to be integer, so we will convert it into integer. Okay, a1. So this is what it will be doing, append. Then we have append left as well, append left. So same thing with else if I'll take it. So this will be elif, right. Instead of append we have now append left, and here also append left, right. Let me do the same thing for what, pop left and pop right. So this will be elif, this will be pop, this will be empty, and this will be again pop, right. Now again I'll have same thing. So here I can do something called pop left, here also pop left, right. So total I think 4 we have to do it. So if pop left, yeah, I think so, that is done. So if I'll run the code, this is how it will look. There is no response because we have not printed anything. So let me print it. Print D. Let me submit it. So here you can see we have 1 and 2, which is correct, but we have to represent in this fashion. So what we can do is print, we can use something called join space separated dot join D, right? Is something we can do. Okay, we have to convert it into string first. So each of them we have to convert into str. So str comma D, then mapping I can use, right? This we have learned. If I'll use this, then we can see we have our answer. Okay, if I'll submit it, all the test cases are passed. Congratulations. So we have done the work. If you want to use something else, then you can use a shortcut way, which is just put a star and D. That will also work. That will make it space separated. So you can use both of them. Okay, you can see. If I'll submit it, all the test cases are passed. Also we have to put the constraint. So let me put the constraint here. Constraints. Okay, if the value of n is less than equal to 0 or n is greater than 100, then print value of n is out of range, right? And we will stop the program. System.exit. It will not go ahead, and for that we need to import sys, right? So we are done with the program. So what it will do, it will check and instantly it will exit the program. Okay, if you won't write this, it will come here and try to execute it, which we don't want. That's why I import sys all the time. Let's check. Yeah, and it's done. Okay, 0 and 3. Yeah, so we have finished this exercise. It is similar to what we have done before, so nothing new. It is just we are instead of applying it to a set, we are applying it to a DQ, right? So that's it. Let's go to the next challenge.